Now in today's lesson, we're going to focus on ports and protocols. So this is one of the most important topics in networking because it explains how applications actually communicate over the network. Many students memorize port numbers for exams, but that is not enough. So as a network technician, you must understand why port exists, how protocols work, and how to troubleshoot them when things go wrong. So if a service is not working, 9 times out of 10, the problem is related to the port and protocols or security rules. So just imagine the internet is this massive global shipping terminal. Right? So thousands of ships arrive every second from all over the world. So without a system to manage where they go, and how the crew speak to the dock workers, it would be absolute chaos. It would be chaotic. So port and protocols are the dock numbers, right, and the languages that keep the digital world organized. Now, why do port exist? Well, let's start with the question: why do ports and protocol exist? So imagine a server that runs a website, email, file transfer, and remote management, all on the same IP, all on the same IP address. Without ports, the server will not know which applications will receive the incoming data. So protocols define the rules of communication, such as how the data is formatted and how the devices will actually respond. So ports act like doors on the building. So the IP address is the building, and the port numbers is a specific door to actually use to access a service. So without ports and protocols, modern network will not function. I mean, in the early days of networking, computers only did one thing at a time. Right? Your computer is a multitasker. So you might be watching a YouTube video, downloading a file, and chatting on WhatsApp web at once. So the problem is that all the data comes into your computer through one single physical cable. It's not like you're connected to multiple Wi-Fi, or you've got multiple Ethernet cables that are connected to a computer. It's one. You're connected to only one Wi-Fi, right? So how does the computer know which data belongs to which, to where, or belongs to the video player, and which one belongs to the chatting app, right? So the solution, the ports and the protocols, they ensure that the data doesn't just reach the right house, which is your IP address, but the right room, that specific application that is supposed to reach. Now, a protocol is a set of rules that defines how communication happens between devices. It specifies how connection starts, how the data is sent, how errors are handled, and how the connection ends. Protocols ensure that the services, or rather the devices built by different vendors, they can communicate. For example, when you use a web browser, both your browser and your web server understand the HTTP or HTTPS protocol. So if either side does not follow the protocol correctly, then what happens? The communication actually fails. Now, a protocol is just a set of rules that governs how the data is formatted and how it's transmitted. So think of it as a language. So let's say if you walk into a bakery and then you try to order bread, so the baker only speaks Sotho, right? And then here I am, I do not know Sotho. I'm not getting any bread if I don't know how to communicate with that person. Okay, so you both need to agree on a protocol. So we both need to agree on a language of communication, let's say in English, to successfully exchange information.
Okay.
So when your browser requests a web page, it uses HTTP or HTTPS as a protocol. Both the server and your browser agree on how to ask for the page and how to send it back. All right. Now, what is a port? Now, a port is a logical communication endpoint that is used by transport layer. So we've already talked about OSI model. So it's used by a transport layer. It tells the operating system which application or service should receive the incoming traffic. So think of a port as a numbered mailboxes inside of a building. Right? The IP address delivers a packet to the building, and the port number delivers it to the correct mailbox. So ports allow multiple services to run at the same time on the single device without any conflict. Now, it's just a port is just a logical connection, really, point identified by the number. That's all it is. If the IP address is the street address of the building, then a port number is a specific apartment number or building number. Okay. So let me give you a scenario. You send a letter to 123 Melville Road, then that's the IP address, but the building has 65,535 different mailboxes inside. If you want the web server to get the letter rather, you put apartment 443 on the envelope, right? And port numbers, they range from 0 to 65,535. So they are divided into three main categories. We've got well-known ports from 0 to 1023 are reserved for common services like web, email, DNS. And then we've got registered ports are used by specific applications and vendors. And then dynamic ports are temporary ports assigned to client devices during communication. For example, when your computer opens a website, it uses a high random number port to communicate with port 443 on the web server. So the range is 0 to 1023. It's well-known ports, so it's reserved for universal services like HTTP, FTP, SSH, and then 1024 to 49,151. So those are registered ports used by specific software vendors like Microsoft SQL or Steam. And then from 49 dynamic ports, 49,152 through 65,535. So those are temporary ports, which is used by PC when you start the connection. Now let's talk about UDP versus TCP. So those are the two main transport protocols, TCP and UDP. So TCP is a connection-oriented and reliable. It establishes a session, ensures that the data arrives in the correct order, and then retransmit lost packets. UDP is connectionless. It does not guarantee delivery. It's faster and is used where speed matters more than accuracy. In real world example like downloads, if you download, it uses TCP. Video streaming, watching a live game or football game, and voice call, it uses UDP. Right. So that's why sometimes, I think you've seen this, you watching maybe a football match, then maybe it loses quality a little bit for a few seconds. Sometimes it's like a squeaking noise or something like that. That means that the packets are being dropped, but then they are not retransmitted because we want to watch this live game. We don't want to stop before they score the goal just to go back and then resend the lost packet. And then instead you just hear a squeaky noise or maybe it drops in a quality or something like that. So it uses UDP. TCP, if you're downloading a file and then let's say certain packets are dropped, it's gonna go back and then retransmit. That's why it will tell you 10 seconds remaining, and then After a while, then it goes back and now it recalculates, and then it's 1 minute because it's trying to retransmit the lost packet. So this is also called windowing. We'll talk about that a little bit later on. So the TCP is reliable, it's polite and organized. It uses a three-way handshake, all right, to ensure that the connection is solid before sending data. If the packet gets lost, TCP asks for it to be sent again. For example, sending an email, you want every single word on your email that you're sending to arrive in a correct order. If a piece of email is missing, then the message might not make sense. And then the UDP is fast, it's reckless, and efficient. It doesn't check if the receiver is ready, so it just blasts the data. If the packet is lost, it's gone forever. I made an example with a live video streaming, live sport game. So if 1 pixel of data is lost during a live match, you don't want the stream to pause and request that pixel again, right? You want the video to continue playing in real time. So that's UDP. Now, let's look at some of the common application protocols, HTTP and HTTPS, that are used for web communication, and then FTP and SFTP are used for file transfers, and then SMTP, POP3, and IMAP are used for email. DNS translates domain names into IP addresses. DHCP automatically assigns IP addresses to devices. So as a technician, you should know not just the port numbers, but what each protocol actually does. So application protocols like the web and mail, the HTTP is on port 80. It uses port 80, unencrypted web traffic. So it's rarely used. Okay, it's rarely used. And then HTTPS is a secure encrypted web traffic, and it's on port 443. Okay, it's on port 443. DNS is on port 53. So DNS is like a phone book of the internet. It turns names like google.com into an IP address like 8.8.8.8. Okay. And then DHCP is for is to assign IP or network configuration into a computer, or into a device rather. I think it's on port 67, if I'm not mistaken, 67 and 68. I'm just not 100% sure. I forgot to actually write the ports down. All right. Then we've got the management and remote access. All right. Network devices and servers are often managed remotely. Right. SSH provides a secure command line access, and then Telnet is an older, insecure protocol that should not be used on modern networks. RDP allows remote desktop access to systems, and then SNMP is used to monitor network devices. So in a secure environment, only encrypted management protocol should be allowed. Now SSH runs on port 22 and stands for Secure Shell. It allows you to log into a remote computer securely. It's like a teleporter for admins, right? And then RDP runs on port 3389, remote desktop protocol, used by Windows to show you a graphical view of another computer screen. Telnet, I think, is on port 21, all right, but it's not. You should not use that because it's a very old protocol. Then when it comes to voice and video communication, so this introduces voice and video communication introduce unique challenges. Protocol like SIP establish calls, while RTP carries the voice and video data. So these protocols, they prioritize low latency over guaranteed delivery. So a small amount of packet loss is better than delays. Okay, so this is why voice traffic behaves differently from file transfers. So SIP runs on port 5060 and port 5061 for session handling. Is actually session initiation protocol. So this is what rings the phone when you make a voice over IP call, like on WhatsApp or Teams or things like that. And then RTP is a real-time transport protocol. So this carries the actual audio and video data once the call is actually connected. All right. And then voice over IP is just voice over the internet, really, or IP. Now, every open port is a potential entry point for attackers. Firewalls are used to control which ports and protocols are allowed. So a common security principle is least privilege. Only open what is absolutely necessary. Example, a web server should only allow ports 80 and 443, but block everything else. Okay, because misconfigured ports are a common cause of security breaches. In the world of cybersecurity, the open port is just a potential unlocked window or unlocked door. Alright, so if you leave port 21, which is a file transfer protocol, open, and oh yeah, by the way, I said Telnet use port 21, right? Also, FTP will use port 21, so they use the same port. If you leave FTP open, file transfer protocol, and don't have a strong password, then the hacker can climb through that port and steal your files. Now, firewalls, they act as security guards. Alright, so they look at the port number of the incoming traffic and say, you're trying to come through port 22. Do you have an ID? Nope. Access is denied. So there's a job of a firewall. IT professionals use tools like Nmap to scan their own network to see which windows or ports are actually left open. So always follow the principle of least privilege. If the service doesn't need a port to be open, and then you just shut it down. All right. Now, let's walk through a troubleshooting scenario. Let's say from a web service that is actually down. Now, a user reports that the website is not loading. First, we verify the network connectivity, then we check whether the service is running. Next, we confirm the correct port is open on the firewall. Right. So if port 443 is blocked, then the website will not load, even if the server is online. That's how ports and protocols guide through troubleshooting. So, remember the symptoms that you just deployed an app or a web app on the new Ubuntu server. So you try to access it with https://myapp.com, but the browser says error, connection refused. So step one, the first thing is to check is whether the server is even listening for visitors. All right, since you are using HTTPS, the server should be listening on port 443. And then, so you need you SSH into your server port using port 22, and then you run netstat to check which port is actually listening on. So if you see that maybe 443 the door is open, then if you don't see it, then your web server might be crashed or misconfigured. It's like you arriving at a shop only to find the entire building is missing. You see, all right. Now, sometimes your web server, let's say, is running perfectly, but the server's firewall or the cloud security group, like in AWS or DigitalOcean or Azure, is blocking the traffic. I want you guys to go and watch the video there on YouTube on cloud computing. I think it's load balancing. Just go and watch, and then you'll see when I open the port 443 or port 80 rather, to allow the connections to the server. Okay, so the protocol is correct, HTTPS is correct, and the port is active, but the security guard hasn't been told to let port 443 traffic through. Who's the security guard? Is the firewall. He hasn't been told that, you know what, you must let this person through. So you need to run some commands to allow certain on your firewall to allow 443. So this tells the firewall anyone knocking on the door 443 with the TCP request is allowed in.